use this video lecture to solve one of the popular problems in string manipulation. This is called reversing a C++ string. So we're using C++ string by including this string template header files. So what does that mean by reversing a string? Let's say if this string is C++ string, and this string is C++. If you do a reversal, reverse, then what you end up with is ++C, right? So reversing every single character is inside a string is what this means. This function takes in a input string. So this input string could be anything, right? C++ or college or something like that. And is reversal being the return type. So, and that's it, right? There are generally two ways to solve this problem. Going by the previous demo, where we saw the use of a temporary buffer, right? String, return, val, right? If you set it to be an empty string, and what you do is if you have, right, this is some string that you have here, and to solve this problem, you can set up a integer I, right? And this integer I iterates from the end of the string, right? Which is basically the length of it minus 1, because array indexing starts with 0, all the way towards index 0. And as I lands on a character, it basically ships whatever that is, right? S bracket I into this, right? So how do you concatenate return val? Return val plus equal, right? Si. And notice that this I goes from the back, right, towards the front. At the end, after that one iterations, right, when I goes into 0, return val would have everything in reverse, right? So this is the first one, the first way to solve it. Let me annotate this is in different color. So you can see that the memory consumption for this one is it requires this one. This one is 24 bytes. It's pretty heavy. The other one is integer I, right? This is 4 bytes. So we can say that this memory, the requirements for solving this using this method requires a total of 28 bytes, right? Now, I mean, you can count other stuff too, but like just capture the bigger stuff. And the second solution that we're going to be illustrating, actually, we will be illustrating using this one, is let's just do an in-place swap. What happens if this is in-place swap? So the idea is very simple, right? Again, this is your input S, right? The idea is to have two pointers, right? Pointers in the generic sense. We're not talking about C++ pointer, right? We're talking about basically having a left and right. They're directional indices, okay? So left is this, right is this, where you have left just plus it towards the middle, and right minus, right? So the direction of R goes from the very end of the string towards the middle, L going from index 0. So the end of the string is S dot size, right? Minus 1, because array indexing is 0. Sometimes people do S dot length. It doesn't matter, okay? Both of these are available in C++ string libraries. So the idea is that once you go through this, and let me illustrate this too using a different color, so you can see if at any moment where L and R lands on, from a string character perspective, you want to do a swap, right? So as L moves towards the middle, as R moves towards the middle, as they converge together, right? Every single moment, every single iteration requires a swap, right, of the two characters. So this is a swap. So as you learned in maybe other languages, where when you do a swap requires a temporary variable, right? This temporary variable, when you do a swap, is a char. Why is it char? Well, when you do a SL, right, or SI, right, this returns a characters, right? So when you do a swap, you're swapping a characters. You're not swapping in a string, substring, so to speak. Substring is very expensive because every C++ string is 24 bytes. So we want to avoid use of a string in general. So what this means that with this temporary char being a requirement, we'll illustrate this soon. This one is 1 byte, right? So what about the 2 R's, right? There's a 2 directional indices we're talking about, right? So this one is 4 bytes, R, right? So it's L, left pointer, is another 4 bytes. So what you have is a total of how many bytes? 4 plus 4 plus 1, right? So this is a total of 9 bytes. Now, just by looking at this, it's the same while loop, right? This is O of n. Actually, in this case, the number of iterations here is length minus 2, right? Divided by 2, right? This is n divided by 2. And this is actually n, right? Assuming there's n characters in it. So solution number 2 is much, much faster in time and space. Time means less iterations, right? Space means less memory consumptions. So this is 9 bytes total, relatively speaking. This is 28 bytes, right? So solution number 2 actually beats out solution number 1 by a fair margin in both time and spaces. Okay, so without further ado, let's illustrate how 2 is done, right? Solution 2. This involves the swap, right, and temporary characters. So we'll go into more details. If you don't see it, it takes a little while to sink in. This is normal, okay? So let me just quickly go through the implementation details for solution number 2. So let's just copy this. We've got the API documentations here already. Before we run it, let's make sure that this entire code actually works. This is from using one of the online IDEs. You can go on CPP, SSA. There's so many of them out there. So the first thing we need to do is set up let's just call it, just to be really explicit, and this is left is 0, right? 0 is the very first index. And our right, this is another 4 byte. This is actually s.length or s.size minus 1, right? Indexing start with 0, so you have that. In C++, you can have them all in the same line like this. So you can declare a whole bunch of variables at once. And now let's do a swap. Now this swap is interesting. This swap requires a char, right? Like we said, char variables. We can actually just leave it as is. We don't really swap variables, which is this thing. And then we do a while, right? This is where we have both L, right? And both left and right converging towards the middle. So the way that we do it is we do left and right, like so, right? As long as left, this is actually left in this. It's less than right in this, we just keep going, right? This iteration just keep going. So the swapping mechanisms in C++ or in the OOP is very straightforward. What you can do is you can take one of them. In this case, we're going to take the left one, right? And say we're going to store that left inside this temporary variable, and then we're going to do the actual swap itself. So this is swapping left and right, right? And then what you do is you can assign that temporary variable back into right, because we took it out of the right. Now we're going to push it back in. Actually, no, we took it out of the left. Now we're going to push it back into right. So this allows us to do an in-place swap, meaning there is no change to S in general, but other than the character itself being swapped internally using making use of this temporary char variable. Okay, so with that, the other important thing is, and never forget to do that, is left is then going to be avenged towards the middle. And right is going to be, so basically left and right, there will be converging, right, towards the middle. Now, this is important to note. Let's just illustrate this, as I want to make sure that everyone is on the same page. This is S, right? So you have right going this way, and then you have left going this way. And you may be asking, Professor, what if S has even number of characters? Well, if this is the even number of character, then it's cool, because you know that at some point, right, you're gonna have a pairwise swap all the way through. There's no problem, because this is not an odd number. So at some point, left and right will be crosses each other, and this will invalidate this condition, ending the entire solutions. But what if, Professor, if we have odd number of them, let's just make it really small so we understand this. And this is right, and this is left, right? Left is going this way, right is going this way. That's fine, because what will happen is you will have the middle part being the pivot, right? This will never be stepped on, but what is outside of this pivot will be swapped. And as soon as L and R converges on the same pivot, which is that even number right in the middle, or the odd number right in the middle, this will have invalidated this condition as well, right? Because this condition says left less than, right? So in both cases, either S having even number of characters or S having odd number of characters, it does not really matter. This logic will satisfy both, right? So this is very important. When as a budding developing software engineers, you gotta sometimes think about these, think it all through, and make sure this all makes sense. So this gives us what ultimately a swapped, right, completely reversed string in general. But this is not correct because we're missing a whole bunch of stuff. We have to return it, right? So what do you return this with? This is basically it. In fact, because S has been changed in place, there's really no need to return it at this point, because I'll get into this, right? Because what you're passing into this function is a copy of the S, but the S is already changed, so you can simply not have to return it. But in this case, we're returning S anyway. And if you do a cout, so we're going to quickly make this up. Let's just input C++, right? And just to be pretty oriented to the end of line characters. So the cursor will go into the next line, right? So if you do another one, college, and do a run, let's look at this, right? So basically what we have here is the memory constraint here. So what is this? This is a char, right? So this is 1 byte, right? And this is 4 bytes, right? And 4 bytes. 4 bytes. So this is a total of 9 bytes. And how many iterations we have? Right? This is the iterations that we need is s.length, right? Divided by 2. Why is that? Well, because you have this converging towards the middle, right? So it only requires half of the length, the iterations, to get this done. So this is the most efficient way of getting your string reversed in C++.